Hello everyone. I'm going to show how to set up the RC Receive driver block and then go ahead and deploy it to an Arduino Mega 2560. This RC Receive driver block will allow you to program your Arduino with Simulink to control your RC aircraft or ground vehicle. First, we'll set up the environment. This only needs to be done once per version of MATLAB. Type vir at the MATLAB command window to see which toolboxes are installed and activated. Then we need to make sure that we have a compiler. I type max-setup and see that I have a few compilers available. I select Microsoft Windows SDK 7.1 and that finishes the configuration. If you do not have any supported compilers installed, you can download it by searching in your browser for MathWorks supported compilers or by going to the following link. Then we install the target support package for Arduino by typing target installer at the MATLAB command window, clicking install from internet, selecting Arduino, and then going ahead with the process to install that target. We need to set up the driver block to obtain three files that are necessary: a TLC, C++ wrapper, and MEX file. This only needs to be performed once. When you download the folder RC driver block, you will find the following four files. The viewer model is not included and was just added to allow you to see an example that I have prepared. First, we make sure that the current folder is RC driver block, where these files are located. This is the case here. Then we open the RC Receive model. We double-click on the RC Receive S-function builder block. Notice that the S-function name is sfcn_RC Receive. We'll need that in 1 second. I click Build, and the necessary files are generated from this block. One of the files is called sfcn_RC Receive_wrapper.c, which needs to be modified to handle the C++ code that it contains. To do so, I type modify parentheses s-function_RC Receive, which is the name of that S function that we saw before. This performs the necessary modifications. Notice that the extension for the wrapper file changes to .cpp. Okay, that concludes the setup for this block. Whenever we run a model with this RC Receive driver block, we just need to make sure that the model and the following files are located in the current folder: sfcn_RC Receive.tlc, same_wrapper.cpp, and the same thing .maxw64. Let's set up the model to run on the Arduino Mega 2560. To do so, I'll navigate to Tools, Run on Target Hardware, and then select Options or Prepare to Run. If this was the first time I was opening the model, I would see Prepare to Run instead of Options. I select Arduino Mega 2560 from the Target Hardware drop-down, which brings up a configuration page. I go ahead and select OK. At this point, I am ready to build code for the model. As you can see, the block signal feeds into a scope, a display, and a threshold of 1750. The display block shows the value of the signal line, which is the length of the servo pulse from the RC receiver in microseconds. The signal is a 4x1 vector because there are 4 channels set up. When a value in the signal is greater than 1750, the output from the threshold is a Boolean 1, and the corresponding digital pin 12 to 9 is set to a high of 5 volts. These pins are connected to LEDs and thereby cause the LEDs to turn on. We have two choices here. We can deploy to hardware, which will generate code from the model and deploy it to the Arduino. Or we can set the mode to external and click Run to run this model in external mode. This will generate code from the model, deploy it to the Arduino, and have Simulink communicate with the Arduino so we can monitor and interact with the code. I will go ahead and deploy this into external mode by clicking Run. The code has been deployed to the hardware. Since we are in external mode, we can monitor the signal's value in the display and scope blocks, which means that we really don't need the LEDs to make sure that the code works. The display block gets populated with the length of the servo pulses in microseconds. And then if I open up the scope, you can see that as I change the value of the first channel, the scope and display block get updated appropriately. Let's open up the viewer so that you can see my setup. Okay. As you can see, the RC transmitter is transmitting the value of the 4 channels to the RC receiver shown here. The RC receiver is powered by the 5-volt and ground lines that are coming directly from the 5-volt and GND pins on the Arduino. The RC receiver is sending the 3 servo signals to pins 2, 3, and 18 on the Arduino through those 3 signal lines, through those 3 wires. These signals are being thresholded by the value of 1750, and that resulting Boolean, which was on the right of that model, is being outputted to these 4 wires through pins 12 through 9 and is being sent to the LEDs. Okay. If I increase the channel 1 to the top, the value becomes 2000 and the corresponding LED at pin 12 turns on. When I change channel 2's value to the right, to the max of 2000, the corresponding LED turns on as well. Same thing occurs with channel 3. If you want to change the sample time, or the pins at which the signals are received, I'll show you how to do so. If you look at the RC receive block shown here, you'll notice that the value for the sample time parameter, TS, and the pin numbers parameter, pins, are variables instead of numeric values. I'm passing in variables because I want the values to come from variables stored in the model workspace or from a mask. You can access the model workspace by typing Ctrl-H or by navigating to Tools, Model Explorer, and then drilling into the model workspace shown here. I can go ahead and change the values of the parameters by simply clicking on the values field and modifying it. If instead I wanted to use a mask to pass in the variables, I would right click on the block, create subsystem from selection, then go to mask, create mask, parameters and dialog. I'll add 2 edit boxes so that I can enter them manually. Okay, and as a result, when I double click on the subsystem, it says enter sample time, enter pin numbers. Okay, to figure out what pin numbers you can use, please see the documentation for attach interrupt on the Arduino website. These pin numbers are different for each board. The Arduino Uno only has 2 pins that can be used for this. Arduino Mega has 6, and there are a couple other boards, I believe. Okay, if you want to see the full version of the RC receive model with the mask, just look for the RC receive _ masked model. Okay, thank you for watching the video, and I hope this helps you start flying and driving your vehicle with Simulink and Arduino. Thank you.